And as you've just seen, that's how the best of the best go about troubleshooting electrical concerns. Now let's talk about some specific electrical concerns, what their causes are, and how to repair them. Buick is using more computers and microprocessors in their cars each year. Continual development of better, faster, and smaller microprocessors and circuit boards means more computing power in every system. One example is the PCM, Buick's most powerful onboard computer. In 1997, Buick began producing a new type of integrated circuit known as a Chasm Chip, which essentially does away with many of these bulky circuit boards and the wiring needed to connect them. All of the circuitry is inside the chip. This chip is comprised of several layers. These chips are manufactured to form a layered microprocessor. Dozens of electrical connections are made without large wiring and the related electromagnetic interference. Another characteristic of the Chasm Chip is its provision for faster two-way communication between modules. This is known as Class 2 communications. Park Avenue and Riviera route Class 2 data through the Chasm Chip to communicate with the PCM, the EBCM or EBTCM, the standard body module, and the HVAC module. The Chasm Chip is found in the instrument cluster and in the body control module in the Regal and Century. In addition to simplifying the electronics of the car, the Chasm Chip holds the vehicle mileage in its own EEPROM. For all of the capabilities of the Chasm Chip, intermittent concerns have been noted in some early cars. Like all intermittents, they may be very difficult to reproduce in a service bay setting. These concerns include an instrument panel performing a key-on bulb check while driving, a speedometer that drops to 0 while driving, gauges that drop to 0 or go to their upper limit, the electronic prindle blacking out, a trip odometer displaying incorrect readings, an ABS system that is not able to reset the tire pressure indicators, erratic air conditioning system operation, or warning chimes that sound at a faster rate, a slower rate, erratically, or not at all. Regal and Century Chasm Chip concerns are similar, but with these cars, concerns are limited to the BCM and the instrument cluster. Even so, technicians might be stumped by a no start and DTC P1626. DTC 1626 is a passkey code. A technician following the PCM controlled starter diagnosis will be instructed to install and program a new PCM with a Tech 2. Then, when you switch the ignition on to set up the PCM programming sequence, the engine may start cranking and won't stop until you switch off the ignition. This happens because the new PCM has not yet been programmed to disable the crank enable relay. This concern actually originates inside the BCM. 97 and 98 Regals and Centuries no longer use a passkey decoder module. All key decoding is performed by the BCM. If the BCM is defective, it can't identify a valid key code, so the BCM uses Class 2 communications to inform the PCM that an invalid key is being used. The PCM correctly disables the starter and injectors and sets DTC 1626. If this happens, take the PCM out and reinstall the original PCM. The original PCM is not the cause of the problem. Replace and program the BCM. The relearn procedure is rather lengthy, but every BCM reprogramming step is in your know-how reference manual. Now let's get to the heart of the matter, and that's electrical repairs. I'll state the obvious by saying that proper repairs require the proper tools. The Delphi Packard Electric Terminal Repair Kit is an essential tool for Buick dealerships to update their original terminal repair kit. Since the original kit went into service about 10 years ago, many new terminals have been designed. The original tools are compatible with terminals on the newer cars. The new kit box is larger to hold 3 additional trays of replacement terminals. The following specific Park Avenue and Riviera electrical concerns have been identified and corrected by Orion Assembly Plant workers in Lake Orion, Michigan. With Orion's comprehensive quality control program, cars with these concerns are identified and repaired before leaving the factory. Still, there may be Buicks on the road that, over time, may require attention when an electrical concern presents itself. Let's start with a disabled ABS and traction control system. The amber ABS and red traction off warning lamps will be illuminated, and one or more ABS or TCS codes may be set. This symptom has multiple causes. The first cause is on early '97 production cars. The rear wheel speed sensor wiring connector mounts to a bracket on the rear suspension support. Workers couldn't actually see the 2 connectors to assemble them. If terminals are damaged, the wheel speed sensor signals will be affected and codes will be set. If the damage is on the body harness side of the circuit, repair the damaged wiring using the Delphi Terminal Repair Kit. The wheel speed sensor jumper harness uses special high-flex wire. A repair in high-flex wire creates a stress point at the repair. The wire may break. Avoid a comeback and replace the harness. The bracket for the connector was moved forward a few inches to help reduce this concern. A second early '97 model concern is a separated or broken jumper harness. The jumper may be pinched between the control arm and the park brake cable, separating the wire inside the insulation. If the harness is damaged, replace and reroute it. The third ABS concern may occur as each vehicle travels from one assembly station to the next on an assembly platform. For 1998, engineering provided a longer ABS harness. Workers clip it to the quarter panel while other components are installed. Sometimes it falls and hangs at the side of the assembly platform. If the platform bumps something or the harness gets caught in the assembly platform drive pulleys, the connector can be cracked or broken, or the wiring may be damaged. If the assembler doesn't see the damage, the connector is assembled. Shorts, opens, and ABS DTCs may occur after the car leaves the plant. Replace broken connectors and repair damaged wiring. Now let's talk about a no start. As you know, when the transaxle is in park or neutral, the park neutral position switch completes a circuit between both theft relays in the underhood junction block and the PCM starter enable relay control input. Now, when the air cleaner housing is installed, the harness is pulled aside. The yellow with black tracer wire, circuit 625 from the park neutral position switch, may stretch and break inside the insulation, or it may be pulled from the connector. Installing the PCM connectors may also stretch the park neutral position switch wires. If wiring concerns are not caught at the factory, any no-start concern should include an electrical check of the park neutral position switch wires and their connections. Next, let's talk about an inoperative radio on a '97 or '98 Riviera. The radio harness branches forward at the left side of the radio. In '95 and '96, the harness connected to the right side of the radio. For '97 and '98, the radio harness enters the IP carrier near the harness breakout point. The harness length was not changed, so assemblers had to loop it back. However, these wires may be crushed between the IP brace and bulkhead as the IP is installed. Pinched wires may short to the sheet metal to prevent radio operation. Disconnect the battery. Remove the radio from the instrument panel. pull the harness through the IP entry point until the suspected damaged section is accessible for repairs. This next concern covers speakers that don't work when the radio is switched on. There is no sound coming from the radio, regardless of the volume setting. As you can see, the radio appears to function normally. What happens is the car has a cellular telephone readiness package, but no telephone. The radio thinks a phone exists, so it mutes the volume until the call is completed. This is known as radio logic lockup. You need to reset the radio's memory by removing and reinstalling the radio fuse or the negative and then positive battery cables for 3 to 5 minutes. Remember, always remove the negative cable first and connect it last. Once the radio sees that a cellular telephone is not a part of the car, the radio's volume operates normally. This next concern involves the glove box lamp. During installation of the lower IP assembly, the glove box lamp pigtail is held aside. When the pigtail is connected to the IP harness, these wires may be pulled out of the glove box light connector. Repair or replace any damaged wiring and reconnect the connector. For a defog button that stays on continuously, let's look at this wood grain trim piece. A wood grain laminate is applied to a metal fascia that's folded over a plastic base. On the straight portion of the base, the laminated metal fascia is folded over properly. These corners of the fascia must be precisely cut and glued to these contoured corners. If the metal is cut improperly or it comes loose, an edge protrudes that catches the defog button to hold it in the on position. The current repair is to install a new trim piece. Be sure to check the new piece for proper fit and adhesion. The underhood lamp switch on some cars may not illuminate the lamp. The switch consists of a metal ball inside a barrel housing with electrical contacts. As the hood is raised, the ball rolls to the back to touch the contacts and illuminate the underhood lamp. If the ball sticks in the barrel, the lamp won't illuminate. Also, the lamp may flicker if the ball is not making good electrical contact. If the switch isn't working correctly, drill out the rivets and replace the lamp. Be very careful. The hood brace is very close to the hood skin. A technician can be in for a lot of work when a car arrives with an engine harness wrapped around the serpentine belt and pulleys. Retaining fasteners secure the harness to the sheet metal. One branch of the harness is routed and secured to the base of the right strut tower with the retaining fastener. On some cars, loose fasteners may allow the harness to be caught in the serpentine belt. The pulleys literally rip the harness from the car and wrap it in the serpentine belt system as the engine quits. Check each fastener to ensure it is fully seated. Technicians may encounter difficulty evaluating generator performance, resulting in unnecessary generator replacement. The Universal J41450B CS generator tester is an essential tool, although it's not listed in the service manual as a diagnostic tool. This tester helps you quickly determine if a charging system problem is caused by the generator or by the related wiring or control components. The tester isolates the generator from the vehicle's control circuits, allowing the technician to check the direct performance of the generator. You'll also need your ammeter and carbon pile load tester. The diagnostic LED on the generator tester indicates whether the generator is charging within the set points. If the generator is okay, you can then concentrate on diagnosing the problem within the wiring or the generator control circuit. So let's see how this tool is used. First, inspect the drive belt. It should be in good condition and have proper tension. Loose, damaged, or corroded wiring at the battery or the generator should be repaired. Then, check the battery's state of charge. It should have a green eye and produce about 12 volts on a voltmeter. When you're getting ready to use the tester, look it over, making sure that both four-way connectors have tight, undamaged terminals. This prevents a poor connection that could give you a misleading finding. Now, let's go over the self-check procedure. Perform this sequence if you think the tester isn't working. Connect the black tester clip to the negative terminal. Connect the red clip to the positive terminal. The green power LED should light up. The LED will not light if these leads are reversed. Replace the tester if the LED does not light with proper connections. Make a jumper harness from an alligator clip, wire, a MetroPack 150 terminal, and an inline 100 ohm resistor. I'm using a light bulb for the resistor. Connect the jumper to the negative battery terminal. Insert the MetroPack terminal into the L cavity. This checks the red diagnostic LED. Check the other connector too. If the lamp lights in both connectors, the tester is okay. If it does not light or only lights in one connector, replace the tester. Remove the jumper wire and disconnect the tester from the battery. Connect an ohm meter to the red battery lead and then use a MetroPack 150 terminal probe adapter to connect the black lead to the S terminal. A reading of 1400 to 1600 ohms means that the tester is operating normally. If the reading is not within this range, replace the tester. Both four-way connectors should be tested. Once you know the tester is okay, connect the red clip to the output terminal of the generator and the black clip to the generator frame for power and ground. The green power LED should light. If not, wiggle the clips. If the green LED won't light up, check for voltage between the output terminal and the negative battery terminal with a DVOM. If you get battery voltage, that means the generator isn't grounded. With the generator ground restored, the green power LED should light. That's the self-check procedure. To test the generator, disconnect the vehicle harness connector and connect the matching tester connector. The red diagnostic LED should light. If the indicator doesn't light, switch the ignition on, but don't start the engine. This 5-amp fused jumper lead has a MetroPack 150 terminal and a ground clip. Clip the jumper to a good ground and touch the MetroPack terminal to the L terminal of the vehicle generator connector. If the fuse doesn't blow, that means that the regulator has already been ruined. Then check the vehicle connector. If it doesn't have an L terminal, replace the generator. However, if the fuse does blow, the L circuit is shorted to power. It's miswired or it has improper resistance. Regardless, excessive power on the L circuit has wrecked the regulator. The wiring concern on the L circuit must be fixed prior to installing a new generator. If the red LED is on, switch off all accessories and start the engine. If the red LED stays on, replace the generator. If the red LED goes out after a few seconds, raise engine speed to 2,500 RPM. Increasing RPM makes the generator produce its full output. If the red LED comes on, replace the generator. If the red LED doesn't light, apply a load from a carbon pile while watching the ammeter. Adjust the carbon pile load until the ammeter reaches 70% of the rated output of the generator. If the red LED doesn't come on, the generator is okay. If it did, replace the generator. Remove the carbon pile load and allow the engine to idle for a moment before switching the ignition off. Remove the tester and reconnect the vehicle harness. If the generator passes but the charging system concern still exists, the source of the charging system concern is in the car's wiring, not in the generator. If the tail lights on a Riviera don't work, check the taillight harness. It runs along the right side of the trunk and across the back of the car. A portion of the harness may be trapped by a retaining nut. Pinched wires that short to ground prevent taillight operation and will typically blow a fuse. Loosen the taillight assembly nut to free the trapped wire. Repair the damage using the terminal repair kit. This door harness for the power windows, door locks, and mirrors may rub through on the window regulator stud. Over time, vibrations may cause the harness to rub through and short the circuit. Visually inspect the wiring for signs of damage. Use the terminal repair kit to repair the wiring. A 98 Riviera with a variety of drivability concerns may have a damaged 78-way connector. Connector C101 connects the PCM harness to the engine harness. In order to install C101, this heavy harness needs to be pulled aside. This harness is very difficult to move because it has so many wires. Connector C101 can only be installed after the powertrain and C102 are installed. If the terminals in C101 are not lined up, they may be damaged. The potential areas of concern depend on which terminals are damaged. A full range of drivability symptoms are possible, including a no-start condition. Use a Tech 2 to monitor the data stream. Inconsistencies indicate that connector C101 should be examined for damaged or backed out terminals. Damaged terminals should be replaced. Recently, there was a product improvement where the factory added a new clip to hold the C102 harness out of the way, although not on this particular car. The new clip makes installation easier, reducing this concern. Another concern involves power windows on 97 Century and Regal. The driver's door switch may intermittently operate the rear power windows. The glass may go down, but not up. The A-pillar pass-through allows some wires to become rubbed through by the park brake mechanism. The rear window up circuit shorts to ground, preventing the window motor from operating. Remove damaged wiring and repair it. Reposition the repaired harness so that it won't contact the park brake mechanism. If the power door locks cycle while driving on a rough road, the driver's door armrest bracket may be pinching a door lock wire. Every time this wire grounds, it simulates a lock or unlock request to the BCM. Door unlock pulses are sent to operate the door lock motor every time the wire grounds. Repair the wiring and reposition the harness. '97 Century or Regal customers have mentioned a Magna Steer malfunction. It turns out that the system is okay, but a Magna Steer wire has rubbed through on a transaxle case bolt. Look for this where the Magna Steer and park neutral position switch circuits splice into the PCM harness. Repair the wire and reroute the harness away from the bolt. Owners of a 1997 Regal or Century may mention that the MIL light is on. You'll also find DTC P0440, meaning the system has detected a very small EVAP system vacuum leak. This EVAP DTC is very sensitive to differences in fuel tank pressure during a vacuum diagnostic run by the PCM. This code can be caused by a loose gas cap or a poor connection at the fuel tank pressure sensor connector. Start the engine and verify sensor operation with a Tech 2. Use the Tech 2 to close the vent valve. Momentarily open the purge valve to draw a vacuum on the system. Then monitor fuel tank pressure. 1.5 to 1.7 volts indicates a loose gas cap. 2 or more steady volts indicate a sealed system. 0 volts indicates a loose connection that should be repaired. If a customer comments that the MIL light is on and the fuel gauge fluctuates, check for DTC P0108, P1106, and P1635. Service manual diagnostics will tell you to replace the map sensor. A new map sensor won't fix the car. The next step is to replace and flash a new PCM. However, that won't fix the car either. Now what? During a fuel tank leak test at the supplier plant, water may have entered the fuel tank pressure sensor connector, shorting the reference circuit. All 5-volt reference circuits are branched from the same regulator in the PCM. If one connector shorts, all 5-volt reference signals are pulled low. The map sensor circuit is sensitive to reference signal fluctuations. When voltage is affected, the PCM sets multiple unrelated codes. The repair is to replace the fuel tank pressure sensor. Once the assembly plant determined the process problem and notified the supplier to correct this, no cars have had this concern. Just remember that customers drive through slush and puddles, over speed bumps and through potholes. Vibrations and time can also create electrical concerns. Keep this in mind when diagnosing any 5-volt reference circuit. Thanks for watching this Buick Know-How program featuring Buick's best technicians. Get in the hunt for the 1998 competition and sign up now. Experience firsthand that you do have what it takes to compete at the regionals and nationals. The Buick Expert Service Team welcomes all technicians. Sign up and maybe we'll see you in the winner's circle.